Hey everyone! Today, we're looking at an absolute paradigm shift in what artificial intelligence can actually do. For a long time, we've basically measured AI progress by its ability to, say, write a polite email, or maybe generate a functional Python script. But what happens when an AI crosses the threshold from simply assisting us to actually generating net new scientific discoveries? Okay, let's dive into this, because the information we're unpacking today fundamentally changes the entire trajectory of theoretical research.
I want you to think about how you use AI right now, or at least how you see it used in the mainstream. Do you think artificial intelligence is merely a coding assistant? Or, maybe a highly advanced chatbot to help you brainstorm some marketing copy? That perception is incredibly common, but it's about to change, dramatically. We are officially stepping out of the realm of simple text generation and into the realm of profound, literally unprecedented problem solving.
Because on August 1st, 2026, a truly historic announcement dropped. AI didn't just write a better algorithm, it solved decades-old math problems. And get this, it did so for what basically amounts to pocket change in compute costs. We're looking at a genuine scientific breakthrough arc here, one that bridges the gap between deep theoretical mathematics and modern computational economics. Let's look at exactly what happened and who's behind it.
Section 1. Meet OpenAI Astra.
So, on August 1st, OpenAI officially confirmed that its next major model family is called Astra. They revealed that an internal version of this model achieved exactly 10 major breakthroughs. It literally solved 10 open problems in mathematics and theoretical computer science. And to be crystal clear about the gravity of this, we are not talking about high school homework problems here. These were deeply complex, open questions that had seen absolutely zero progress for at least a decade. Human mathematicians had been completely stumped, hitting brick walls year after year.
Let's walk through the specific problems conquered here. Now, what's really interesting about this is the very first one, the existence of non-sofic groups. This is a highly complex group theory question first posed by Mikhail Gromov way back in 1999. Think about that. For 27 years, no mathematician in the world had been able to prove or disprove it, until Astra. Along with that, the model successfully disproved Kahn's rigidity conjecture in von Neumann algebras, it proved Ehrhart's volume conjecture, and it resolved 3 entirely separate problems from Paul Erdős's famous catalog, including problem number 183 on Ramsey numbers.
And it doesn't stop there. Beyond those massive historic conjectures, Astra also established new bounds on high-dimensional sphere packing and new bounds on circuit complexity. This is absolutely vital to note because it shows the sheer breadth of Astra's capabilities, right? It's not just a one-trick pony that somehow got lucky in one specific narrow niche of group theory. It's demonstrating a sweeping, generalized capability across really wide-ranging disciplines of computer science and deep mathematics.
Section 2. The $2,000 breakthrough.
As fascinating as the complex mathematics are, we really need to shift our focus to the economics of this discovery, because this blew my mind. Generating all 10 of those historic results, including that 27-year-old unsolved problem, cost roughly $2,000 in API compute. That figure is based on OpenAI's GPT 5.6 Sol API pricing. Just think about that number for a second. $2,000 to accomplish what decades of human intellectual labor literally could not.
Let's put that into perspective with a concrete analogy. Resolving problems that had stumped the brightest mathematical minds on the planet for 27 years was accomplished for, well, about the price of a high-end laptop. You're looking at $2,000 in compute, directly stacked up against 27 years of unsolved human math. The return on investment for that compute time is just staggering. It tells us that the cost of novel, genius-level scientific deduction is plummeting.
Of course, we all know extraordinary claims require extraordinary evidence. The tech industry is pretty famous for its smoke and mirrors. So how do we actually know this is real? Well, OpenAI didn't just drop a flashy press release and ask us to take their word for it. No, they released a highly detailed 249-page manuscript. And alongside that, they published the formal proofs plus the model's own reasoning walkthroughs directly on GitHub for anyone to scrutinize.
To prove the absolute rigor of their work, they used a verification system called Lean4. If you look at the GitHub repository, it shows what's called a sorry count of 0. Now, in the Lean4 formal proof system, a sorry is essentially a placeholder for a step you haven't quite figured out yet. So a sorry count of 0, that means absolutely no step in any of these formalized proofs was left unproven. And this brilliantly illustrates exactly why the mathematics community is taking this whole thing so seriously. The proof is mathematically verified by a strict structural system.
And independent experts?
they're incredibly impressed. Just consider this statement from Tim Gowers. He's a Fields Medalist, which is essentially the Nobel Prize of Mathematics. He reviewed the work and stated, "I would recommend one of these proofs for publication in Annals of Mathematics without hesitation." That is literally the highest level of validation you can possibly get in the mathematical community.
Section 3. A crucial reality check. However, as with any major tech advancement, we need to take a step back and apply some necessary skepticism. Let's look at the data objectively. If we trace the timeline, we can contrast this current verified announcement with a past incident. In October of 2025, OpenAI executive Kevin Whale claimed that GPT-5 had solved 10 previously unsolved Erdős problems. That sounds incredibly similar to the August 2026 announcement we're discussing today, right? Where Astra announced 10 lean verified proofs. But the reality of that 2025 claim was very, very different.
When that 2025 claim was made, Thomas Bloom, who is the mathematician that actually runs erdősproblems.com, publicly pushed back. He called the claim a dramatic misrepresentation. Why? Because as Bloom correctly pointed out, the 2025 model hadn't actually generated novel proofs at all. It had basically just scoured the internet and found existing obscure papers in the literature that Bloom himself wasn't even aware of. It was a search engine achievement, not a mathematical one.
So the crucial point here is understanding the structural difference between these two events. The 2025 claim, that was about finding existing literature. The 2026 reality with Astra is an entirely different beast, because these proofs are lean verified, they're public, and they've been independently reviewed by experts like Gowers. They are net new generations. Now, as a completely neutral reminder, it is important to note that while these 2026 proofs are highly credible, they still haven't gone through a formal peer-reviewed journal process just yet. We're still in the early days of verification.
Section 4. The future of AI. Let's move to and see how this builds into the broader landscape of technology. First, it's absolutely vital to know that Astra hasn't even been publicly released yet. It is strictly an internal model undergoing testing at OpenAI. They haven't even confirmed what the official consumer name is going to be. Will it be GPT-6 or maybe some completely new naming convention? Investors like Mark Kretschmann are already heavily speculating that Astra is indeed the foundation of the GPT-6 series, but right now it remains safely locked behind closed doors. But OpenAI is definitely preparing for a massive rollout. Alongside the math breakthrough, they made another huge announcement regarding scale. They are giving 100,000 academic researchers free access to its frontier models through the year 2027. They're actively putting this unprecedented computational power directly into the hands of the academic community.
Which leaves us with this final, monumental question to consider. If an internal, unreleased version of a model can solve 27-year-old mathematical mysteries for just $2,000 in compute, imagine what's going to happen when this model reaches the hands of millions of researchers, students, and engineers around the globe. The democratization of this level of intelligence isn't just going to change mathematics, it's going to completely reshape the ceiling of human potential. This story is far from over, and as soon as Astra officially launches, we'll be right here to explain exactly what it means for you. Make sure to subscribe so you don't miss that update, and thanks for joining me on this explainer.